Welcome to astronomy. In this video, our group will discuss a set of hypotheses about galaxies we've derived based on our given data set. The data has led us to 5 important fundamental questions. How does color relate to the mass of the galaxy? How does color relate to high-density clusters? Are ellipticals and spirals more likely to be closer to clusters and high local density areas? What are the colors of these ellipticals and spirals as you get closer to clusters? Is axial ratio more likely to be greater or smaller in local density? Let's now expand on these details of our compiled data and see what we found.
From our data, we found that 82.1% of all ellipticals and 82.5% of all spirals have a valid near-cluster distance, of which ellipticals are more likely to be closer to the center of a cluster than spirals are. To answer the question about color of ellipticals and spirals, 10 megaparsecs of a cluster, we found that the G-R values of ellipticals within 10 megaparsecs tends to stay around 0.75, while the G-R value of spirals within 10 megaparsecs can range between 0.25 and 0.9. To determine if axial ratio is more likely to be greater or smaller within a local density, we found that ellipticals tend to have an axial ratio between 0.5 and 1, while spirals can have an axial ratio mostly between 0.25 and 1. There seems to be no correlation between the axial ratio and the near cluster distance, except for the fact that there are higher density of galaxies with 2 megaparsecs of the center of a cluster. To look at the color of galaxies within clusters, we found that the percentage of redder galaxies increases as you get closer to the center of a cluster. We also looked at the color of galaxies versus the mass of the galaxy, and this shows that a large number of galaxies have a G-R value of around 0.75, and most of them weigh 10.15 mass of the Sun or more. For methodology, here are some examples that we used to determine how we might go about solving G-R value, or the mass, or the redshift. We have the largest galaxy, the middle galaxy, and the smallest galaxy present. In conclusion, we found that the percentage of ellipticals is higher within clusters. Ellipticals stay relatively redder, while spirals are bluer, but become slightly more redder as they get closer to the center of a cluster. We also found that ellipticals usually have an axial ratio above 0.5, while spirals can have an axial ratio between 1 and 0.25. There is no real pattern of axial ratio as you get closer to the center of a cluster. Also, percentage of red galaxies within a cluster increases as you get closer to the center of a cluster. And as clusters get larger, the percentage of red galaxies also increase. Future research can look at the color of galaxies relating to cluster mass, the color of galaxies based on location in the sky, and also further classifying galaxies into ellipticals and spirals. Thank you.
Throughout this project, we have seen that science is not as black and white as we once thought. We had originally thought that it would be simple to look at the data and create classifications. We have since learned that nothing is as clear-cut in science as we would like it to be. We were always able to find outliers or pieces of data that didn't fit to the norm that we had expected. This taught us that the nature of science is much more complicated and interconnected than we once thought. This caused us to always strive to find new ways in which we could manipulate the data in order to try to better prove one of our hypotheses or to just see what other interesting trends or questions we could find.